We move on to different types of physical quantities and their unit. What is a physical quantity? Any quantity that can be measured, we call it as a physical quantity. All the physical quantity has a number and a unit. 50 is the number, meter is the unit. 2 number, second the unit. So all the physical quantities have a magnitude. Magnitude means the number. Look at this, 45 is the magnitude. And the unit is Pascal. Now, what is the unit? We learned during need of measurement, it is used to compare an unknown quantity with a standard unit. My house, how far is it? I have no idea, but I'm comparing it with a known unit, kilometer. How far is it? 25 kilometer. What does that mean? Distance is 25 kilometer, which means the distance from my place to my house is 25 times a known unit, 1 kilometer, another 1 kilometer, another 1 kilometer, another 1 kilometer. How many such? 25. The distance from my place to my house is 25 times the standard unit. Remember, 25 is the magnitude, kilometer is the unit. Look at these quantities. I made some measurements. You can see one, another one, another one. Do you have any idea what are they? No idea unless you specify the unit. Look at this. The first one is 1 kilometer. You have an idea, that much distance. Next is 1 centimeter. Oh, very small. 1 millimeter, even small. If I'm saying 1 kilometer per hour, that is something else. Speed. I'm saying 1 second, time. So by seeing the unit, you have to know which quantity is that. I'm giving something for you. 25 Newton. Newton stands for unit of force. This is 25 Newton, which is force. And if I'm saying 25 meter square, so this is the area. What are the fundamental units? You know the 7 fundamental quantities, and the units of those 7 fundamental quantities, we call them as fundamental units. The first fundamental quantity is length, and the unit is meter. Second fundamental quantity is the mass. The unit is kilogram. Third one is time. So the corresponding fundamental unit is second. Temperature, the unit is not Celsius, it is Kelvin. Next, amount of substance, mostly we use in chemistry. Mole, the fundamental unit. And the last fundamental quantity is luminous intensity, which is brightness of the bulb. The corresponding fundamental unit is candela. Now we go for some derived quantities and the units. You knew it before. Speed, it is meter per second. Acceleration, so anywhere if you see this unit, it is acceleration. Anywhere you see meter square, it is a derived unit. And what quantity is that? Area. Kilogram per meter cube, which you remember, density, which is a derived quantity, which depends on 2 fundamental quantities. Kilogram for mass, meter for length. Energy, the unit is joule, but joule can be expressed as a combo of these fundamental unit. Force, kilogram meter per second square, which is Newton. Pressure, kilogram m-1 s-2, which is Pascal. So these are the derived units. So what are the derived units? The units of derived quantities. We move on to the characteristics of a unit. There are certain characteristics. The first characteristics of a unit is it must be having suitable size and easily available. You have only 100 and 200 grams with you, and you want to measure the mass of an elephant. Gram, is it enough? No, you need kilogram. So the unit should be easily available and it should be reproducible at any place required. If the object is very huge, you will go for kilogram, and smaller ones, gram, milligram, etc. And reproducible, which means if you have 1 kilogram, what is the conversion? Just 1000 gram. So it is reproducible. From kilogram, you can make gram. So the first characteristics of a unit is it should be of suitable size depending on your requirement, and it should be easily available. Second characteristics, it should be universally acceptable. Distance is measured in meter, accepted everywhere. Some people will say distance is in mile, confusing. So we always prefer meter. Quintal is a unit of mass. No idea. But when you say kilogram, it makes sense. So it should be universally acceptable. Kilogram is universally acceptable. Gram is universally acceptable. Kilometer, meter, centimeter, millimeter, etc. are universally acceptable. Minute, second, hour in measuring time, which is universally acceptable. These are the three quantities you have to remember in grade 11 physics. Now, another characteristics of unit, it should be invariable all over the world. It should be well defined. See, today it is 1000 gram. Tomorrow it changes into 800 gram. No, it should remain as invariable time to time. 1 kilogram means 1 kilogram. Same anywhere in the world, the same. So it should be invariable and well defined. It should not be perishable. It should not change with time and place. That is the meaning of that. Now, we go for the relation between the units of a physical quantity. In grade 11, you may measure distance. You may need to change from one unit to another. Look at this. 1 kilometer is 1000 meter, which is a smaller unit. Smaller unit is meter. Larger unit is kilometer. But look at the number. When you change from a larger unit, kilometer, to a smaller unit, meter, look at the size. Changes from 1 to 1000. What does that mean? When you change into a smaller unit, the size increases. I'm changing into kilogram. For smaller to a higher unit, the number should decrease. 1 gram, how will you change it into kilogram? Divided by 1000. So you are changing to a higher unit, but look at the size. It becomes smaller. Rule. The size is inversely proportional to the unit, which means if you go to a higher unit, the size becomes smaller. If you go for a smaller unit, the size becomes higher. The same thing can be written in mathematics like this. Number and the unit. Look at this. Number and the unit. 1 kilogram equals number and unit in another unit. Look at this. Same. 1000. 1 unit, another unit. N1 stands for number in 1 unit. N2 stands for number in another unit, kilometer, meter. Now let's do some MCQs. Read the question. Dash is the standard unit of a physical quantity. What does that mean? Do you think it's a quantity? No, it's a unit. Now let's go for the next question. It's assertion reason type. When we change a unit of measurement, the numerical value changes. It is true. Look at this. So assertion is true. So this is wrong. Smaller unit of measurement, smaller is its value. Let me write one thing. 1 kilogram, 1000 gram. Gram is a smaller unit. Look at this. Do you see the number becomes smaller? No. So this is wrong. So assertion is true. Reason is false. So the answer is C. Now another assertion stating that a car is moving with a speed of 50. Remember, no unit. Is significantly, scientifically meaningless. Yes, we don't know whether it's moving with 50 meter per second, 50 kilometer per hour, no idea. And so assertion is true. So D is wrong. Then what does it say? A numerical magnitude alone cannot completely represent a physical quantity. True. It requires a standard unit. That is also true. So reason is true. Now between A and B, and reason is the correct explanation for the assertion. So the answer is A. Another one. The unit written alongside of a number is the primary way we identify specific physical quantity. 20 meter distance. If it is 20 seconds, time. So that is true. So this is false. Different physical quantities can share the exact same numerical value. See? Same numerical value in a given problem, making unit the only way to identify them. True. Reason is also true. So this is wrong. And sure, the reason is the correct explanation for the assertion. So the answer is A. We go for system of units. Different types of system units are available. What are they? There are 3 different system units. FPS, foot, pound, second. CGS stands for centimeter, gram and second. MKS, meter, kilogram, and second. So these are the 3 system units. What is FPS system? Length is measured in foot, mass is measured in pound, time is measured in second. Same way, now you will tell me what is CGS? Length in centimeter, mass in gram, time in second. What is MKS system unit? Length in meter, mass in kilogram, time in second. This is internationally accepted system units. So we call it as SI system units. The French word system international, the unit as English system of international units. We write short SI units. And these are the 3 things you have to know in grade 11 mostly. Current, which is in ampere, temperature in Kelvin, these 5. Let's do some questions. Which of the following is the characteristics of a unit? Number 1, it is universally accepted. It must be invariable, should not change from place to place. Well defined. Correct. So the answer is D, all the above. A standard unit is necessary for the sake of course, that makes more accurate, that helps you, convenient, that keeps uniformity everywhere. So the answer is D. Look at this. Historically, scientists and engineers in different parts of the world utilized completely different units such as FPS, CGS, MKS, etc. So assertion is true, which means D is wrong. Let's see the reason. Before the era of rapid global communication between them, different places, no communication at all long before, but now quick communication available. Units of measurement were developed locally, true. On regional convenience, true. And historical customs, etc., etc. Reason is also true. So this is wrong. Now between A and B, do you think reason is the correct explanation for A? Yes. Before there were no proper communication, so they used different units in different places. So reason is the correct explanation. So the answer is A. Another assertion reason, even after MK system became widely adopted, scientists sometimes prefer using CGS for specific experiments. We use centimeter, gram, second, etc. So assertion is true. In CGS system, it is more mathematically convenient when dealing with very small quantities. True. Or specific field like electrostatics, avoiding uses of small decimal values, especially in chemistry also you use gram, etc., etc. That is also true. Between A and B, the reasoning is the correct explanation for the assertion. So the answer is A. Another assertion reasoning question. Operating different system units like CGS, FPS, MKS globally accelerated the process of international everywhere accepted. So that is true. D is wrong. Using different system units across different parts of the world created confusion. That is also true. International trade, which led creating internationally accepted single unit. That is also true. So this is wrong. And between those two, do you think reason is the correct reasoning for the assertion? Yeah, that is a reason.